Hey, it's John Broadwell, creator of the Serial Wombat open source project. Today's January 30th, and the purpose of this video is to show a prototype and talk about the latest upcoming product in the Serial Wombat line, the Serial Wombat 8B board. The 8B board is interesting. It runs... You may know the Serial Wombat line from prior successful products, such as the Serial Wombat 4B, or the Serial Wombat 18AB, which was the subject of a successful Kickstarter campaign in 2021. The purpose of a Serial Wombat board or chip is to act as smart I/O expansion for another board such as an Arduino. You don't program a Serial Wombat chip in most cases. You send it commands over I2C and it acts as a smart I/O expander. In this particular example, we have an Arduino Uno clone that's running some Arduino code. We've downloaded the Serial Wombat library from the Arduino Library Manager, and we're going to show a sample sketch where we talk to the Serial Wombat chip and have it enable pins 2 and 3. Pin 2 is going to go to this servo, which is attached to a rack and pinion linear actuator. Pin number 3 will go over to this analog input. And so we'll be able to see how the Serial Wombat chip can act in place of a variety of different existing I2C expansion boards because of the flexibility presented by the microcontroller in here. And we'll talk about this micro here in a minute. But for a minute, on to the demo. We have power coming into the Arduino board from a 5-volt USB battery. We have a second power supply that's going to supply power to the servo because it's always a good idea to separate power supplies for your electronics and inductive loads. And then we can move this guy, and we see that the linear actuator moves to match the position of the potentiometer. You'll also notice that it does not happen instantaneously. That's because the Serial Wombat chip is monitoring one pin and then adding filtering to the output to limit the rate at which the servo moves. We could make the servo move as fast as we want, but a common use case that confuses new Arduino users is when they want a servo to move slowly rather than quickly. Later, when we take a look at the code on the Arduino, we'll see that after setup, the Arduino is doing absolutely nothing. All of the real-time control is happening within the firmware of the Serial Wombat chip. For those of you who are already familiar with the Serial Wombat chips, the code running in here, the pin modes, are identical in interface to the Serial Wombat 18AB that you're already using. So in this case, we're using an analog input pin mode, a scaled output mode with rate limiting on the servo. You could run that exact same example on the Serial Wombat 18AB and it would function identically. So now let's take a quick overview of some of the exciting Now let's take a quick overview of how the features and how the development of the Serial Wombat 8B board is going to develop. The Serial Wombat 8B board is based on a very inexpensive microcontroller called a CH32V002. The Serial Wombat 8B board is based on a very inexpensive microcontroller called a CH32V003. And this opens up a lot of possibilities. Number one, this chip, despite the fact that it has a 32-bit core, is significantly cheaper than the PIC16F microcontrollers that I use for the Serial Wombat 4B. Secondly, this chip is in stock at my board manufacturer, JLC PCB, so I can have these boards manufactured at a very low cost. And my expectation is that I will be able to generate one of these 32-bit 8 I/O boards cheaper than I can manufacture one of the Serial Wombat 4B chips. So that opens up the possibility for you to have a whole bunch of these in your toolbox just ready to go. My goal is to potentially be able to sell 10 to 15 of these guys in a package for $20 by the time that we get done with the Kickstarter and on Amazon and all that kind of stuff. So that's a price point at which other I/O expanders can't compete, despite the fact that the Serial Wombat chip is much more capable than most of them. I'm very excited about this. So the code here is based on the Serial Wombat I2C template that is under examples, and a lot of this code was automatically generated using the Serial Wombat panel application. So we're going to instantiate a Serial Wombat chip, we're going to instantiate the analog input that we have the slider on, and instantiate a Serial Wombat servo 18AB. Note that this class, because it has the same interfaces on the 08, will be used on the 08 and the 18AB. I'm going to have to probably figure out some way to make that look good. So we've got both of these guys tied into that Serial Wombat chip. We're going to do a wire begin because this is an I2C device. We're going to do serial begin in case we use it, which we actually won't right now. Delay 100, give these guys a chance to start up. Serial Wombat begin. Since we know there's only one of them on the bus, go out and find it. And then analog input begin on number 3. We'll do some filtering and filter constants and all that. Attach a servo to pin number 2. And then we will use the output scaling capabilities that tie one Serial Wombat pin to another so that they can interact with each other. And we'll say, hey, I want the servo to move based on the input on pin number 3, which was our analog input. And I want you to put rate limiting on this. I only want you to be able to move 10 counts out of 65,535 every 1 millisecond, or that would be 10,000 counts, or about 1/6 of the range per second. So with this rate control, it takes the servo about 6 seconds to move from its full left to its full right, regardless of how fast you move the input slider. And if we take a look at loop, you will see here's the real power of the Serial Wombat chip. Once the Arduino sets up the registers inside of the Serial Wombat chip state machines, the Arduino doesn't have to do anything else. All of that moving the servo, the rate control, all of that stuff is handled off board by the Serial Wombat chip. So, if you had higher level decision making to do, if you also wanted to read this analog input, you could do that. If at some point you wanted the Arduino to take over control, and go into an automated mode, you could certainly do that. You can command and control the whole thing from the Arduino chip. Lots of people do that. But as you get more advanced, you can also offload those to the internal pin state machine interactions. So that's all I have for today. Hop on over to the Kickstarter page and sign up for updates. Maybe if the campaign is open at this point, maybe throw me a pledge or two. So until we talk again, have fun, keep making stuff.